Hello React Native developers, I hope you are well. William here, recording from beautiful Zurich, Switzerland. There are two components you've been asking me to implement on this channel. The first one we've implemented a couple of weeks ago was the Android ripple effect. And the second one, which we're going to implement in this video, is the iOS-Style picker. As you can imagine, implementing such an example is everything we love about gestures and animations in React Native. Some fun trigonometry, well-orchestrated gestures and animations, and using the now very powerful masking capabilities in React Native. Let's have a look. All right, so we are into the code here, and I have some boilerplate. I am looping over the values, and here I have a container which depends on the number of visible items. So the height depends on the number of visible items, and overflow done to hide all the other elements. So you see these that go outside the container height. And we're going to implement this in 3 steps. First step is the gesture. And for this, we're going to use a pan gesture handler, use redash in order to calculate, depending on the velocity, where we need to snap, because we need, when the gesture ends, to have one value selected. For this, we could use the scroll view. You would get everything for free, the snap to interval feature, and it would work amazing, but you wouldn't be able to have a default value. So if the default value is 1990, you couldn't do this with the scroll view. So the scroll view in React Native doesn't provide us with capabilities for default values. So we're going to use the pan gesture handler instead. Second step, we're going to use trigonometry to make it look like these values are rotating around the wheel. We're going to look at our trigonometry wheel, but it's a bit different this time because it's as if we were looking at it from profile. So what is usually the x-axis becomes the y-axis. And so we're going to calculate. So the rotation, the translate z is going to be the cosinus of our rotate x, and translate y we have, and we can calculate rotate x based on the translation y would be the a sin of translate y. And then we can use the mask element from React Native in order to have the value selected displayed in white and all the other values displayed in gray like on iOS, and that should give a super nice effect. So let's get started with the gesture, and we're going to create a gesture handler component. Here I separate it into a component just so the code gets clean, because this is gonna grow bigger. So I just prefer to have this logic into another file, but it means that we need to create a animation value, which we're gonna call translate y. So here we're gonna read it here, and we're gonna write it into this component. And so I can pass translate y. Let's create the component. So gesture and so this is the animation value we need to write. So it's an animated value from Reanimated. No. Let's try again. Yes. So we are translate y. So from this point, you guys know the drill. So pan gesture handler, first and unique child of a pan gesture handler is an animated view, and here we want to fill all the container space. So we're going to use style sheet absolute fill. We need a gesture handler, and redash is going to give us all the boilerplate we need for that. So we're going to use pan gesture handler from redash. And we're going to need the translation and velocity vector and the state of the gesture in order to calculate the value we need to assign to translate y. So on every frame, we want actually to assign. So okay, we can assign to translate y some animation value which we need to compute, and we're gonna call it with, let's say, snap to interval. And we're gonna need a couple of values. So we can have value is gonna be translation y, velocity is gonna be velocity.y, state of the gesture, and we need snap points. And the snap points we can calculate based on the item height, and we need the maximum value. So let's do maximum value, max number of items. So we would have max is values.length. Okay. So snap points, we're going to create an array of size max, and for each item we do -I times item height. Right, we start at 0 and we translate from the top to the bottom, so we go negative. That actually looks pretty good. I think we just need to create this function. We need to import this guy here. Oops. So let's create snap to interval with snap to interval. So we have a couple of parameters here. So state, I'm going to call it gesture state, so it doesn't conflict with the state of the animation. So let me create a type here quickly. We're going to return a block of code. Okay. So let me create quickly a type. So we're going to have value velocity state and snap points. Okay. So we have a block. We need a clock for the animation. Actually, this should be a hook. No, that's okay. Actually, let me do new clock. We need an animation state. Here we're going to use the timing animation. So we have position, finished time and frame time. We need a config. So config. So we need two value. We need some easing. So let's have a look here. So we want something that looks like a decay, right? So I'm thinking, yeah, something like this, right? Goes quick and then slow. Something like, I mean, they look very similar. But we want, I think, something that goes very slow at the end. Quick and then slow. I mean, they kind of all look similar. Let's do, oh, perfect. I mean, we can play with this. In fact, yeah, I mean, let's see. This we can tweak later. And also here I'm going to put a fixed duration, but we can also make it depend on the velocity, or we could calculate the exact decaying value with a target. So let me put one second for now. And okay. And we need an offset to remember where we are when we release the gesture. So we have our boilerplate. It's a lot of boilerplate. So the first thing we're going to do is start the clock. We need it to be always running. If the gesture begins, we store in the offset the position of the animation. If the gesture, so it's not state, it's gesture state. And it's state.began. If gesture state is active, we want, sorry, we need to import a couple of things here. We want to set state.position to be offset plus value. And yeah, looks good. And here we return state.position. If the gesture ends, we run our animation. So state.end. We're going to run our timing animation. So we have, I think it's, let's see, what's the signature? It's clock state config. Clock state config. And so this means when we start the gesture, we want to make sure that, when the gesture is active, we want to set state.velocity. No, we don't have state. These we can reset when the gesture begins, so we do it only once. So I'm going to do it here. So state.finished equals 0. And same for time and frame time. I think should be good. And then we can set config to value. And here we use snap point to calculate where we need to go. So snap point from redash. And we pass. So we have state.position, velocity, and snap points. So it doesn't like the config. And it's probably because I import easing from React Native, but I should import it from Reanimated. So that doesn't look too bad. Let's have a look. Okay, we need to import and one is defined but never used. Translate y. And gesture handler we need to import. And we need to import gesture handler here. So nothing is moving, but maybe it's because we're not using translate y yet. So let's have a look. No. Okay. That's terrible. So let's move it here. So translate y. Okay. Much better, and we do have some velocity. So that looks good. Now we can look into adding the rotate X and translate Z. So we are gonna calculate, we're gonna calculate a Y value, but a bit different than translate Y, because we want translate Y, but where the origin is the selected item. So we want to have Y as 0 here and Y at minus, for instance, minus item height times 2 here, and here item height times 2. So we're going to calculate our Y value, which is going to depend on the index of the item. So I'm going to interpolate on. So I'm going to divide translate Y to minus item height to item height. No, minus item height. I want a positive value. And here, so we're going to interpolate. So we're going to have input range. So let's say we have, I think I should have wrote some values here. So relative radius is 2.5. I mean, visible items is 5. And then here we have the values based on item height. So here I'm gonna have minus I times radius relative I, and here I times radius relative. And the output range is gonna be, so actually here I can write -1, 0, 1. Because this is the scene value of our circle for these positions. And so that gives us rotate x, which should be a sin of y. And here we want to extrapolate clamp. So this becomes an animated view. And we're going to create the transform. We can use the perspective value, rotate x. Let's have a look. So something is wrong here. And I think, so it's not multiply, it's, so here we have I minus 2.5, right? Relative radius. So radius relative is radius relative to the index of the selected value. And here it's radius, the point, the value in points. So here would be minus, here it would be I plus 2.5. And here, so we start to have some sort of effect, but it's wrong because the selected value is the one in the middle, not the top one. And so I think here we need to subtract twice, so item height times 2. Okay, I need to put it before the divide. Okay, so now they seem to rotate nicely. We just need to add the translate z. So translate z is simply the cosinus value of rotate x. So we have z is cosinus of rotate x, which we need to multiply by the radius. And then we use the perspective to calculate, transform it into a scale transformation. So Redash provides a helper function for this. Since there is no translate z in React Native, but we can calculate it in this scenario using perspective and the z value. So let's have a look. And we need to remove. So when the cosinus is 1, we need translate z to be 0. And when the cosinus is 0, right? We are at alpha pi. We want to be at minus, so we want to be backward. We want to be at minus radius. So I'm gonna subtract radius to the value. Yeah, that looks good already. Let me reload. Yeah, I think that looks good. And let's add a nice mask element to it. So we can this becomes a view. No, what did I do? So this is going to be our mask element. Mask element. And we're going to use a masked view. So we have our mask element. And here we want to So we're gonna have a view. So we have 3 views. The one at the top has a background color of white and has a height of 2 items. This one has a height of 1 item. And this one is white, this one is gray, and the one at the bottom is gray. You see? Isn't that cool? That looks cool. And you see it snaps always to a proper position. That's fun, isn't it? I think we can really improve this example in many ways. Here, I would like really to... doesn't feel clean. I would really like to calculate rotate X based on the interpolation of our gestures and animations, and then have Y and Z, which are cosinus value here. This is clean, but I would like to calculate, translate Y actually, also based on the sinus value of rotate X, and calculate rotate X based on the interpolation. That would feel cleaner. But I hope you guys enjoyed this example. If you're interested to dig further in the fantastic world of gestures and animations in React Native, I hope that you will check out my online course at startreactnative.dev. My goal with this course is to provide you with all the tools and knowledge necessary in order to build incredible user experiences in React Native that will run at 60 FPS even on low-end devices. And I am closely following all the alpha releases of React Native, and I'm publishing lessons and videos on this topic as soon as they can work properly with Reanimated 2. So I'm trying to keep up to date with Reanimated 2 as much as I can. So if you're interested, I hope that you will check it out at startreactnative.dev. Guys, I hope you enjoyed this example, some fun trigonometry, some well-orchestrated gestures and animations, and we used the now powerful masked view in React Native to be like the final touch in our gestures and animations. In the next video, we're gonna go back to the React Native fashion series, so I cannot wait to talk to you guys soon, and in the meantime, happy hacking.